Hello, everybody. Welcome back to Easy Learn. And today's topic is algebra, within which we're going to be looking at simultaneous equations, also known as systems of equations. In simultaneous equations or systems of equations, we use three methods of solving. Now, one is substitution, the other one elimination, and the third one graphing. We've already discussed substitution in the previous video, and today we're going to be looking at elimination. Now, again, the point of using any of the methods is to be able to find the values of x and y. As you can see, when you're dealing with systems of equations, there are two or three different equations given to us, and in which two or more variables are missing. If I use the first equation, if you look at the first one, it says 5x plus y equals 11. Now, in this particular equation, two variables are missing. So I cannot just simply solve and find out because I need either y to know my x to solve my x, or I need to know my x in order to solve the y. But both of the cases are not available. That's why I need a second equation that could compensate and we could figure out the x and y values. Now, the second equation is 3x minus y equals 9. When we're dealing with substitution, we just isolate one of the variables and then we put that one in the other equation and then figure out. In elimination, it's a little different, a slight different way of doing elimination. And for elimination, there are two steps to that. First one, you need to see that we have the same base. And the second one is that we are supposed to have opposite signs. What do I mean by same base? Base is basically the number that is attached with the variable. For example, in this particular situation, 5x, 5 is my base and x is the variable. Now, if you look at both the bases, let's say this is my equation number 1, this is my equation number 2. Now, what do I have to basically see is that in equation number 1 and equation number 2, the variables that are the same, what bases do they have? So, in equation number 1, the variable is 5x, and in equation number 2, if I take 3x, now the base here is 5, and the base for the second equation is 3, which means that my condition for elimination that says same base is not satisfied when I'm dealing with x. And also, when I'm checking out the opposite signs mean that if this one is a positive 5x, the other one is supposed to be a negative 3x or negative 5x, considering the fact that the bases should be same. But here, as you can see, that there is a 5x and there is a 3x, both of them are positive, which means the signs are not opposite. That means the second condition also not satisfied if I am working out with the x's. Now I can try and see if I can work out the y's. Now for the y, first condition, the same base. Now is the base same? Yes, because y is empty here, which means that there's a 1 here. Again, there's a y on the second equation. Again, there is a 1 here, which means that the condition is now satisfied with the variable y. The base is same. Now, the second condition that says opposite signs. Now, the first one is a positive. The second equation, the y in the second equation is negative, which means the second condition also satisfied. Now I have the same base and I have this opposite signs, so I can eliminate. Eliminate basically means that you have to eliminate one of the variables, either x or the y. Now that I figured out that my y's can be easily eliminated because they have the same base and they have the opposite signs, so I am going to eliminate the y. Let me just get rid of all of this stuff so that it's easier to explain. Now, I have positive y and a negative y. I know that the bases are same. I know that these signs are opposite, so I can just eliminate my plus y and my minus y. Elimination means that you need to get rid of either one of the variables depending on the satisfying conditions. Now, satisfies both the conditions, so I eliminated y. Now, what do I do with the x? Now, whatever stuff is remaining, you add them up, which means that 5x plus 3x and 11 and 9 remains, so 11 plus 9. Now 5x plus 3x gives me 8x equals 11 plus 9. just simply gives me 20. So that means I'm just going to be adding up the stuff that is remaining. Now 8x equals 20. Now I gotta find my x, so I'm gonna take my 8 to the other side. So x is equal to, because 8 is in multiplication here, it goes to the other side, turns into division. So I have 20 over 8. And 20 over 8 is also 2.5. If you check it out on your calculator, 20 over 8 means 2.5. Now that I've got my x, you can put this x inside either equation number 1 or equation number 2 and figure out your y. So let me just select my, let's say this was equation 1 and this was equation 2. So I just feel that equation 2, I should take equation 2, or also you could take equation 1, whichever you think is convenient. So I'm going to take equation number 1 and I'm going to do 5x plus y equals 11. Now in case of my x, I'm going to replace the answer for x, that was 2.5. So 5 times 2.5 plus y equals 11. And 5 times 2.5 is 12.5. So I'm just going to write 12.5 plus y equals 11. Now that I have to find y, I need to make it the subject. I need to isolate it. So I'll take 12.5 to the other side. So y equals 11. And because 12.5 was positive here, goes to the other side, turns negative. So 11 minus 12.5 is supposed to give me 1.5, and negative 1.5, because negative 12.5 is a bigger number. So y equals negative 1.5. Therefore, my x is 2.5, my y is negative 1.5. Now you can either just leave it like that, x equals this and y equals this, or you can write it in a coordinate format. And in a coordinate format, the first one is always your x and the second one is always your y, and you have a comma in between. So x is 2.5, comma, y is negative 1.5. So that's how you figure out the answer. But you just have to remember that whichever equation you have to look at both the equations. In both the equations, you have to see that the bases are same, the signs are opposite. And if that's not the case, then you have to change it, and you have to make sure that you have the same base and the opposite signs, and then you solve, you eliminate, and then you find out the answers. Now let's see another example for that. Now here we have 2x plus 9y equals 43 and 3x plus 2y equals 7. Now again, you are supposed to have the same base and you are supposed to have the opposite signs. Now if you look at this, now if I try and work out the x's, are the bases same? No. Here there's a 2x, here there's a 3x. No base same. Then we have opposite signs. Do these have opposite signs? Here there's a positive 2, here there's a positive 3. Both are positive? No. None of the conditions satisfied when I'm dealing with x. Now if I come back to y, do I see that the bases are same? No. There's a 9 here, there's a 2 here. The bases are not same. Are the signs opposite? It's a plus 9y, it's a plus 2y. Both of them are positive. It's not opposite signs, which means none of the conditions are satisfying. Either I use x or I use y. Now here's the question, what to do. Now the problem is that you cannot use elimination until and unless you satisfy both these conditions. And in this particular situation, we are going to be stuck because the bases are not same, signs are not opposite, and you have to somehow make sure that both of them are the way they should be. So for that, you need to pick out either x or y. Think for your variable which variable you want to deal with and which variable you want to sort of deal with or tackle, and then we pick that up. So if I want to pick up, you can pick up y as well as the x. For me, I'm going to be picking up x for now. So if I check out x, now one of the base is 2 and the other base is 3. What do I have to do is that I need to turn the bases same. Now how can I do that? How can a 2 turn into a 3? How can a 3 turn into a 2? That's technically impossible. So what I can do is I can see that what's the most common factor between the two. So 2 times 3 is 6. So 6 can be a variable, 6 can be a number that would make both the bases same. And how? You need to multiply the 2 with the 3 and 3 with the 2 in order to make them a 6. But you cannot just multiply 2 times 3 6 and 3 times 2 6. If you have to multiply, you are going to multiply the entire equation with 3 so that this 2x can turn into a 6x. Similarly, if I would have chosen y for that case, then I would do 9 and 2 again. I cannot turn a 9 into a 2 or a 2 into a 9, so I would see that which one is the most common between them. So 9 times 2 is 18, so 18 would be common. So in that case, I would do the entire first equation I would multiply with 2 so that the y side turns 18, and the second equation I would do 2 the entire equation I would multiply with 9 so that this 2y turns into an 18y again. But because I've chosen x, so I'm going to do the first equation multiplied by 3 and the second equation multiplied by 2, because 3 times 2 would give me 6. So my target here is to turn the x's into 6x. Now let's see what happens. Now first thing, 3 times 2 is 6x. Then 3 times 9 is 27. So plus 27y equals 43 times 3. That gives me 129. So I'm going to put equals 129. Second part, 2 times 3 again, 6x. 2 times 2 plus 4y. Secondly, 2 times 7 equals 14. Okay, now that I was dealing with my x. Now, are my bases same? Yes. One condition satisfied. I turned my bases into 6. So now I have the same base. Now, the second part of the question, the second problem is that we need opposite signs. Now, both the 6x's are positive. So I need to turn any one equation into negative so that the signs turn negative, the signs turn opposite. So I'm going to pick out again my second equation and I'm going to multiply them with a minus sign. So a 6x multiplied by a minus means minus 6x. A 4y multiplied by a minus means a negative 4y. A 14 multiplied by a minus sign means a negative 14. Now if I just Now this is not your equation anymore. Now my two equations are 6x plus 27y equals 129 and negative 6x negative 4y equals negative 14. Now if you see, do I have the same base? Yes, 6x and 6x. Do I have the opposite signs? Yes, positive 6x and negative 6s. Can I eliminate them? Yes, I can eliminate my x's. And I am left with 27y equals 129 and negative 4y equals negative 14. Now I can just simply do 27y and a negative 4y means I'm going to do 27 minus 4, which gives me a 23y equals 129 minus 14. As you can see, a positive 129, negative 14 means 129 minus 14. That gives me 115. Now I need to isolate the y. I got to take the 23 to the other side. So y equals 115 over 23, which means that I am supposed to get 5. So my y is equal to 5. Now, once that I got my 5, either you can put this y value in this equation or in this equation or in the first equation or in the second equation. Wherever you want to put your y, just put it in and you will get the same value for x for either whichever equation you use. Now, if I'm going to use the second equation, that is 3x plus 2y equals 7. Now I can replace this y with my answer, that is 5. So 3x plus 2 times 5 equals 7, and then 3x plus 10 equals 7. Now I can take my 10 to the other side, so 3x equals 7. 10 goes to the other side, it's a positive. 10 goes to the other side, turns negative. So 3x equals 7 minus 10, which means 3x equals 7 minus 10 means minus 3. And x equals, I gotta isolate the x, take the 3 to the other side. So negative 3 divided by positive 3. So 3 divided by 3 is just 1 and it's negative. So my answer becomes x equals negative 1. My y is 5, my x is negative 1. You can write it in the coordinate format as negative 1, comma 5. So this is my answer. The value for x is negative 1 and the value for y is 5. Now, again, just a little summary that how do we work out on the elimination. You have to always make sure that the bases are same and the signs are opposite. If clearly you have both the things together, you just don't have to do anything, just simply eliminate the stuff and solve it. If you don't have any of that, then you are going to make the bases same by looking at either x or y, whichever you want. Pick out one of the variables that you want to work on, and then make those variables bases same. And for that, you will multiply the entire equation with something. And once you have that, and if the signs are not opposite, then you have to also multiply one of the equations with the opposite sign, so that one of the variable that you chose turns into a positive sign and a negative sign. Once you have all of that, once the conditions are satisfied, you can simply eliminate your variable and then work out and solve the other one that is remaining. And once you get the answer, you can just put it back in either of the equations and check out the answer for the second variable. That's pretty much it. Thank you so much for watching Easy Learn. Do not forget to like, share, and subscribe my channel. If you have any questions, any confusions, you can drop them down in the comment section below. Thank you so much for watching.